Hello guys, when you are building a system, choosing the right database can make or break your application, affecting everything from performance to scalability. Whether you are building a startup or managing a large-scale system, understanding the nuances of different databases is the key. So let's understand different types of databases, their strengths and weaknesses. First up, relational databases. Relational databases such as PostgreSQL, Oracle, and MySQL are the oldest database technology. They use tables to store data, making them excellent for applications requiring complex queries and relationships. They are known for strong ACID compliance, ensuring data integrity and consistency. Now let's understand what ACID compliances are. If you're already familiar with this, then please skip this section. A in ACID stands for atomicity. It guarantees that all operations within a transaction are treated as single unit, which either all succeed or all fail. There is no in-between state. Let's consider an online banking system where a user is transferring money from one account to another account. This transaction involves two steps: deducting the money from the first account and adding it to the second account. With atomicity, if either of these operations fail, for example, the second account is not able to receive the amount for some reason, so the entire transaction is rolled back and the deducted amount comes back to the first account, filling all the transactions and ensuring the user's funds are not incorrectly deducted or added to the account. And when the amount from the first account gets deducted and the second account receives the amount correctly, as in all the transactions are successful, only then we call it a successful transaction. C stands for consistency. Using the banking system again, the database will have some predefined rules, and breaking those rules will bring the database into an invalid state. Suppose the rule over here is an account can never transfer more money than it already has, because then it will have negative balance. If a transaction attempts to transfer an amount more than it actually has, then that would result in a negative balance, violating the database rules, and the transaction will be aborted to maintain consistency. This means the database remains consistent before and after the transaction, and it can only come from one valid state to another valid state. Now I stands for isolation. If multiple customers are transferring money to one another, isolation ensures that these transactions are processed independently, preventing them from seeing or affecting each other's intermediate states. This is crucial for accuracy when multiple transactions interact with the same data. D stands for durability. Durability guarantees that once a transaction has been committed, it will remain so, even in the event of a power loss, crash, or error. This property ensures that completed transactions are permanently recorded in the database. When you need strong ACID compliances, and when the schema is defined and it needs complex queries and relationships, the relational database works perfectly. For an e-commerce system like Amazon, a relational database is perfect for managing customer informations, order, and inventory. Its ability to handle complex transactions ensures that your e-commerce operations will run smoothly. However, when the database does not have a predefined schema, unstructured data like user logs, different product specification, then you might need to look elsewhere. Where SQL database lacks, the NoSQL database shines. Document-based databases such as MongoDB stores data in JSON-like formats, providing a flexible schema for semi-structured data. They allow for nested data structures and are highly scalable. Rather than creating multiple tables, you can store the data in single document. For storing product catalogs with varied attributes or user-generated content, a document-based database such as MongoDB is ideal. However, for transaction-heavy operations and complex relationships, a relational database might be a better fit. A non-relational database might not be the right choice for that. Bridging the gap between traditional relational database and the flexibility of NoSQL, column family stores like Cassandra offers a unique approach to data management. This stores data in table-like structures like SQL database and does not follow any fixed schema like NoSQL. Cassandra is well suited for applications requiring fast data ingestion, real-time analytics, and heavy read and write operations. such as event logging, messaging systems. Its distributed architecture ensures that the database scales smoothly with increasing data volumes, making it an excellent choice for business experiencing rapid growth. However, for applications that rely heavily on complex transactions and relational data models, a traditional SQL database might still be preferable. Now let's talk about key value stores. Redis and DynamoDB are examples of this database. Suppose you have client and server and you need to store cache for the fast access of data. Cache is essential to scale your system. The cache will sit between your client and the server. The client will request the cache for a response it needs, which will be blazing fast compared to normal server response. They excel in scenarios requiring quick lookups of unstructured data. Their main strengths include speed, scalability, and simplicity, making them ideal for caching and storing session storage. But they have very limited querying capabilities, and the lack of complex data relationships make them only suitable for the temporary data storage system. Graph databases such as Neo4j stores data in nodes and relationships, perfect for the datasets where the relationships are as crucial as the data itself. For example, over here, John is following few people and he has liked few posts. Now Jane, who is followed by John, might follow Tom, and Tom is following Jane, Morty, and Rick. You can see how efficiently and beautifully graph databases stores this data. They excel at discovering patterns, making them ideal for social networks, recommendation engine, and fraud detection. But if your database does not have interconnected relations, then using it will be an overkill. Simple relational database or non-relational database would suffice in those cases. At the end, we have time series databases like InfluxDB. This is ideal for efficient storage, retrieval, and analysis of time-stamped or time series data. Collecting temperatures of different time, device logs to monitor any discrepancy in the IoT devices you might have, as well as storing stock or crypto data. It excels in all of these. With time as the primary axis, these databases offer fast data ingestion and real-time querying capabilities, making them highly suitable for time-dependent analytics and forecasting. These are very specialized databases. This will not perform well in general scenarios like managing user accounts or order where traditional relational databases might be more appropriate. There you have it, guys. I hope this video has guided you into the right direction of understanding different databases and choosing the right database for your system. Although you should do a much more thorough research before choosing a database. Thanks for watching. See you next time.